have a problem. We have all these cases of soda to bring up to our room, but we have no way to bring them up.
We can't go down to get them, so we devised a plan using 100 feet of rope in a garbage can to bring them up to us. This is our free body diagram for our scenario of bringing up sodas to your room when you're locked inside and have no other way to do it. So this is our free body diagram here with our force, upwards force of 2,500 newtons, with our dimensions labeled here, and then what we're going to use in order to set up the rest of the problem. Down here we show that in order to find our three forces, we're going to have to use our magnitude of the force multiplied by a unit vector in the direction of that force in order to set up our unit vector and our equilibrium equations.
So we broke up the three different forces in each rope going off to hold up the crate. And here's the position vector of RAB. We broke it up with the dimensions, and then we have to find the magnitude of RAB by squaring each of the terms, adding them, and then taking the square root of that. So we found each position vector and its magnitude, and we did the position vector divided by the magnitude to get the unit vector of each chord for each direction. We have RAC and the unit vector of RAC, and then we did RAD, and we found the unit vector of RAD. And we're going to use those to multiply by the force and find the tension in each of those cables.
So this is our matrix that we're going to set up in order to solve for our three forces. We have our three equations, some of the forces in the y direction, some of the forces in the x, and some of the forces in the z direction. And we have our three unknown forces embedded in these equations, so we'll be able to solve them. In the first one, we took all of our j position vectors and added them together, and because they're in equilibrium, there are some of the forces that are all zero there. Our second one is some of the forces in the x, which is all our I position vectors, and we added those three together here, and those are also equal to zero. And then some of the forces in the z direction is all of our k position vectors, and in this one we actually will have a constant of 2,500 newtons, which is the upward pulling force on the crate. And so we have our three force vectors, our 2,500 newtons here, and that is also equal to zero. So we'll use these three equations, plug them into our calculator, and we'll be able to get solve for all three forces.
And then doing the inverse of the one times the other one. And then we get
our three forces.
After solving the matrix in our calculators, we found the force in AD to be 1,547.6 newtons, FAC is 463.0 newtons, and FAB equals 980.4 newtons. So with the rope that we have, we'll be able to lift this crate with all the soda into my room.
So this is the contraption that we have designed in order to bring the soda up to our room. We have our one rope going up that we'll pull on, and our three ropes coming down, one on each corner and one a little bit ways off the corner here. And these three all together, and when we're pulling up, we'll make sure this stays in equilibrium. This is our attempt to pull the soda up to our room.
Staying in equilibrium, we're bringing up all the soda to our room.